Hey guys, Mr. B here, and in this video we're going to be going through the chapter 14.3 notes on mechanical advantage and efficiency. Alright, so these concepts are going to be a little bit math heavy, but I will do my best to explain what they mean. Okay, so first off, let's talk about mechanical advantage. And what is mechanical advantage? So mechanical advantage of a machine is the number of times that machine will increase in input force. So basically, this is saying the mechanical advantage is how many more times is this machine going to make you stronger? Okay, so we'll say it is how many more times this machine will make you stronger. So is it going to make you 2 times stronger, 3 times stronger, 10 times stronger, right? Think of a car jack. A car jack basically makes you probably 100 times stronger because you push down on a lever and that force is enough to raise a car, which you by yourself cannot raise a car, right? But this machine is making your force way, way bigger. So it's giving you a very large mechanical advantage. It's increasing your force by a lot. Okay, remember, input force is the force you put in. Now, there's 2 types of mechanical advantage, okay? There's actual mechanical advantage. So actual mechanical advantage is the ratio of the output force to the input force. So basically, it's the amount of force the machine does. Oh, let's make sure we keep this in one line. There we go. It's the amount of force that the machine does compared to the amount of force that you do. Okay, input force is you. Now, why is this called mechanical advantage? So this is called mechanical advantage primarily because, and let's shift down our text box here so we can do some typing. Okay. This type of mechanical advantage, and there's 2 types, okay? We'll talk about the second type in a second. But this type of mechanical advantage takes into account friction, okay? This type of mechanical advantage takes into account friction. So remember that friction is always going to be present whenever you are doing anything with a machine. Always. You cannot get rid of friction. So actual mechanical advantage is how much the machine is increasing your force by when you take into account that some of that force that you're putting in is getting lost to overcome friction. Okay, that's actual mechanical advantage. However, there's a second type of mechanical advantage, which is called ideal mechanical advantage, or IMA. And the ideal mechanical advantage is what would be the mechanical advantage of this machine if there were no friction? If friction did not exist, how much would the machine increase your force by? Obviously, friction always exists, which is why we have actual mechanical advantage. But ideally, we can always calculate ideal mechanical advantage first to get an idea of what a machine should be able to do for us. Then we can do it and then calculate actual mechanical advantage, which is how much the machine actually did for us. Okay? So because friction is always present, the actual mechanical advantage of a machine is always going to be less than the ideal mechanical advantage because, again, ideal mechanical advantage does not include friction. Okay, so when we calculate ideal mechanical advantage, we are going to be using input and output distance rather than output force and input force. So again, input distance is the distance that you put in to do your force, and output distance is the distance that the machine puts out for you. Okay, so this is how we can calculate how much a machine should do for us if there were no friction. And then again, this is how we calculate how much a machine will do when there is friction. All right, and then another thing we have here is efficiency. So what is efficiency? Well, efficiency is going to be the percentage of work input that becomes work output. So again, we've been talking this whole time about how you lose work to friction, right? If I put some amount of work on a machine, some of that work is going to get lost and the machine is going to not give me the same amount out because some of it is getting lost to friction. So the amount that you're losing is what is known as your efficiency. Okay, because there is always some amount of friction, the efficiency of any machine is always going to be less than 100%. However, we want to get it as close to 100% as we can. Okay, so if you had a machine that gave you was 99.9999% efficient, that would be the best machine that you could ever make, because you're never going to get 100% efficiency. But to calculate our efficiency, we'll take our work output divided by our work input and then times that by 100% to get it into a percentage. And again, just to remind ourselves, our work output is the amount of work the machine is doing, and our work input is the amount of work that we are doing, okay? So we take the work the machine does divided by the work that we do times 100 to get a percentage. That's our efficiency, okay? We want to get as close to 100% as possible, even though we will never truly get to 100%. We want to get as close as we can. So for example here, if the efficiency of a machine is 75%, then you know that 75% of the work input that you do is going to become work output. So if a machine requires 10 joules of work to be put into it in order to operate, then the amount of work it's going to give you out is 75% of 10 joules, which basically we can take 10 joules times 75% divided by 100, and we would get that 7.5 joules will come out of the machine, right? So we're losing some amount of work, but not that much, right? 75% efficiency isn't great, by the way. It could be better, but it's not the worst either, so. All right, now, because of course, efficiency is very important and we want to increase efficiency as much as possible, reducing friction will increase the efficiency of any machine. And there are, of course, a few main methods that we use to reduce friction, okay? Ball bearings are one, or basically using wheels. So this is why, of course, most things that are very efficient machines-wise have ball bearings or wheels, right? Because they spin. Rolling friction is a lot weaker than sliding friction. And ball bearings, of course, are spherical, so they have rolling friction. Lubricants, such as oil or grease. This is why, of course, in engines, you need motor oil. Otherwise, if you don't have motor oil, your car is going to get less gas mileage, because the engine is going to be losing a lot of power that it's generating and work it's generating to overcome the friction of the metal that's rubbing on each other on all the cylinders, rather than actually taking that work and putting it into rotating the axles of the tires to get your car to go down the road. Okay, this is why you need oil changes every few, 1,000 miles, because the oil gets all grimy and it gets chunks in there, physical pieces of stuff, and that will then make it not as efficient as at decreasing friction, which then will make your engine not work as well. The last thing we can do is also minimizing air resistance. So some machines, such as cars, travel through air when they are going down the road. And a lot of the energy or work that the engine is doing to make the car go down the road has to just overcome air resistance as the car goes through the air. So some of the force that is put onto the axles of the tires to get the car to go forward is just overcoming air resistance. So the more fluid, more aerodynamic you can make your car, the more efficient it's going to be in terms of how well it's going to perform, okay? So these are all very common things that we can do to increase the efficiency of our machines. If you can think of any other ones, though, by all means, do some brainstorming. So, all right, guys, that's it for this section. Pretty short one, but there is some math involved in this one. So there, of course, are some practice problems after this. Hopefully that was very clear, but if you have any questions, make sure that you reach out and ask. All right, guys, I'm Mr. B. I'll see you in the next one. Bye.